My name is Rain Islam, and I'm going to be discussing the chemical processes problem for our Project 2 assignment. And this problem is regarding ammonia production. So, in the problem statement, we essentially must use the equations given to us and the energy balance equations to create various plots. These plots will give us information in order to analyze an ammonia production process. And after we analyze these plots, we will provide information of how we can optimize the overall system. Before we proceed any further, I'd like to discuss a few things. First of all is this image right here. There is nitrogen, hydrogen, and inert gas is being fed into a reactor. From the reactor, it goes to a cooling system, and from the cooling system, it goes to a condenser. So our problem is about ammonia gas, and not all of the reactants or the input necessarily produces the output, which is ammonia gas. So once it enters the condenser, some of it becomes ammonia, while the rest of it, such as the nitrogen, the hydrogen, and the inert gas, either goes back into the cycle, which is being recycled, and it goes back into the reactor, or it purges. And the purge is referring to the inert gas. So the nitrogen and hydrogen get put back into the reactor, and it's essentially like a loop. Now to reinforce this image here, we're given energy balance equations, and essentially we have something that's going in and something that's being produced, which produces something that is being produced out, and consumption, which refers to the loop. And this basically reinforces that image I showed previously. Now to discuss a few MATLAB commands that we used in our code. So we use while loops and for loops. The reason we use while loops is to help us explain the whole system in terms of how it proceeds with the inputs going into the system, and the loop simply supplements the fact that it goes back into the system, and that just helps out with that. And for the for loops, this is simply used for the plotting, and conditionals are both in the while and for loops, obviously, with if and else statements. And plotting is referring to the graph that which produced. And also, I will discuss this further, we have two functions that we created for this problem. And the last but not least, string compare I, strcmp which will be used in task 4, which I will explain. So we're given a total of 4 tasks in order to solve this problem for ammonia production. What I'm going to be showing you next is our algorithm that we produced. So this is also color-coded, so in task 1 is orange, task 2 is yellow, task 3 is green, and task 4 is light blue. So in our algorithm, we obviously start off by entering the data of inert gas, fraction of conversion, and moles being purged. From there, we will call the function with input variables, and that is essentially our task 1. To move on with our task 2, we establish a relationship between two variables. We plot the yp versus np, fsp versus np, and xi0 versus np. And we move on to our task 3, which is we call our function with ideal values to maximize results. This is a rather short task, so we move on to task 4, which we enter the inert gas input, fraction of conversion input, along with moles being purged and moles being fed inputs. This is followed by calling the function with the variables, and this is where we have yes and no, which is being used as the string compare, and we calculate the utility cost. And the question is being asked, would you like to see more values? If the user inputs yes, it will go back into the top of this task and produce these variables. If the user inputs no, this will end the code. Now to discuss the code that we created in MATLAB. We start off with our housekeeping commands. We had to create 2 sections for our problem. So in the first section, it consists of tasks 1 through 3. Feel free to pause the video at any time because there's a lot of information listed here below. And I'll be not going over it just because of the time crunch and the time window that we were provided. So we begin by our code by creating a variable being manipulated, for all three inputs. Our three inputs are the XIO, the FSP, and the YP. And what we did is we simply mirrored the code by switching up the variables to satisfy what we need to do to solve this question. We create an input variable and we enter a while loop. If the while loop is greater than 1 or less than 0, it will give the user a warning. And if it satisfies, or if they enter the correct value, it will move on to the else statement. And this is mirrored, as I mentioned previously, for all three variables. Then we call our function, which is the mass balance function. And our mass balance function is listed here. Once again, pause the video to clearly read all these variables and comments that we have here. And lastly, for task 1, we have our fprint variables, which is listed here. So to move on with task 2, we are graphically analyzing the system. We create theoretical data, and we thought that we had to create a for loop, so we did so, and we used the same function that we created and used in task 1, which is the mass balance function. From there, we needed to simply add the figures. We have our information in code here, which is adding detail to the graph, and as I mentioned previously, we're simply mirroring the code for all three variables, so we simply do the same thing, just for another figure. And lastly, the third figure. And the last task for this section, which is task 3, which is optimizing the system. We just simply created a theoretical minimum, theoretical maximum, theoretical minimum, and we call the same function once again, and we will lastly display this fprint value. So now we will run the code. For demonstration purposes, we're going to enter a negative value just to show what happens, and it gives us a warning. So now we satisfy what the question is asking us by entering a value between 0 and 1 for all three inputs. And it gives us the total moles input of the reactor, which is represented here, the ammonia being produced from the condenser, the overall nitrogen conversion, along with the theoretical maximum for production of ammonia. And we are given these three figures. Figure 1, which is the YP versus the NP relationship, FSP versus NP relationship, along with the XIO versus the NP relationship. Lastly, we'll be discussing task 4, which we created a separate section for, which is we're trying to find the utility cost. And once again, we have our housekeeping commands. And similar to the first 3 sections and tasks, we simply did the same thing. We used a variable which was being manipulated within the while loop. We asked the user to input a variable, enter the while loop. If the value is greater than 1 or less than 0, it gives a warning once again, and is mirrored for all three input variables. Then we have new variable, which is NN inputs. I'll be discussing that later. So the user inputs that variable again, and then it enters the function, which we had to create a new one, which is labeled as utility cost. Followed by that, it will ask the user if they would like to re-enter new variables for this entire section, and we use the string compare I, as I mentioned previously, which is listed here. In terms of the utility cost, there is a lot of information, so once again, just to remind you, pause it at any time. So this is the function for utility cost. I'm just going to scroll down here. Feel free to pause. And to run this function and this part of the code. Enter a variable. Once again, I'm just going to be adding or entering a negative variable. Gives us a warning. So enter the correct variables. Now it says enter a numeric variable in units of kilomoles per hour. We're going to enter that, and we're given a few fprints. The first fprint that we're given is the cost for nitrogen, along with the cost for hydrogen and the cost for inert gas. and this is followed by the cost for ammonia, which will be listed here, and would you like to try new values? We're going to be hitting no for the first trial, and it will say process is over. Now we're going to rerun this entire code once again to demonstrate the string compare I. Just going to quickly enter a few variables. At random, and there we go. And once again, it gives us the different variables for each input variable along with ammonia. And would you like to try new variables? If I hit yes, it will enter the loop once again, and the user will have the power to continue entering new variables as much as they want to until they are satisfied. And if they hit no, as you saw previously, it will end the code. And that completes our code for this problem of chemical processes, which we are trying to solve ammonia production in terms of how we can utilize and optimize this system. Thank you.